The equation for geometric series is A1 times 1 minus r to the n power over 1 minus r. And by the way, you should know this. Okay, you should know this for your quiz. Not your exam though, but quiz. All right, so you have this written down. And now, so I want to bring back what we said about the number earlier. So I would say, remember, okay, what do we say about 0.99 raised to the infinite power? It's practically 0, right? So now, so let's bring these two things together. So now what we are saying, what I'm going to say is this. I would say, all right, if, I'm going to throw an if right here. If the r that you're multiplying, if the r, or the absolute value of r would be less than 1, meaning that it's a fraction. Okay, if r, it's less than 1. Okay, so you're multiplying by a fraction. And n, it's infinity. So what it means practically is that you have infinite amount of terms that you're adding. Okay, so we say, all right, you're multiplying and you're adding a lot of terms together. Then, now I want you to see what's happening here with the equation that you see earlier. I want you to see this here. So if you have an r value that is less than 1, which is a fraction, and then n is going to be infinity, what's going to happen with r to the n power? 0, right? So we can just go ahead and say, oh yeah, that goes to 0. So what's inside the parentheses now? It's just 1. So therefore, if we have infinite amount of terms to add, we have a1 times 1 over 1 minus r. And then you look at the paper, slightly to your left, into the box. That's the equation. So if r is a number that's less than 1, which is a fraction, and you multiply it for infinite amount of times, you are going to find the area. Now let me help you visualize it. What does it mean? Okay, what does it mean? So I can say, well, it means this, okay? It means that you may have a number that starts with 4, but then the r value is, let's just say 3 over 2. How about that? No, 2 over 3, sorry, 2 over 3, and that's less than 1. And then the power, it's going to be the x. Can you see that it is a decaying exponential function? Okay, it's a decaying exponential function. And if you remember what I said about trapezoid the other day, yesterday, I said the series is basically asking you finding the area on the curve. Meaning that what's the area between the x-axis and the curve? And since the value, it's going to get closer and, well, I mean the curve, it's going to get closer and closer to 0. You actually will have a finite area. And that will only happen if and only if the curve is heading toward the x-axis. Now, let's just think about this. If r is greater than 1 or equal to 1, what's going to happen? Well, what's going to happen is that the points will be like this. If I say, can you find out the area underneath the graph? What would you say? What's the area? It'll be infinity, right? So it would not be a finite area. So we'll say, impossible to find area here. Okay, impossible to find area here. But if R is less than 1, then we say, oh, that's nice. Can you find out the area here? Yes. And how? S is equal to A1 over 1 minus R. Done. So that's the explanation of the equation in the box right here. So again, I do not want you to just memorize the equation. I want to give you something more, and that is to know where this equation came from. So this equation and the equation that we did yesterday right here in blue, it looks like they are two separate equations. They are very similar to each other. And I want you to know that they are not two separate equations. They are the same equations. They are the same equation. It's just that the R has a condition and the N becomes infinitely large. And therefore, the whole parentheses will become just 1. And that's why we have this equation now. And now we'll go ahead and look at some examples.